Welcome to Mapazon. This is an application developed by Friends of the Amazon in accordance with Amazon GISNet, an initiative based in Ecuador whose purpose involves assisting indigenous peoples in preserving their culture and environment. The application itself uses tree loss data from 2001 to 2014 from the University of Maryland's Global Forest Change site. We use tree loss as an indicator of mining operations in the Ecuadorian Amazon. These operations cause problems for the indigenous people in the area, as companies seize indigenous territory and exploit it for profit. The purpose of this application is not only to communicate data in an easy manner, but also to raise awareness to the issues that indigenous or oppressed people face around the world. Essentially, our goal is to allow users to walk away with a better understanding of current situations. Now, we will explore the main features of the application and provide some examples of what a user may wish to discover. The primary focus of our application is in-depth visual analysis of tree loss data. To allow for this, our team developed two sliding bars which alter the opacity of the tile layers displayed on the map. The transparency bar on the left controls one specific layer which displays the cumulative tree loss from 2001 to 2014. Essentially all of the data. The bar on the right controls any additional layers the user may use to either compare to the cumulative layer or inspect individually. As mining is a focus of the project, the application features three buttons which zoom the user to identified mining locations. This feature allows the user to explore hotspots on a much larger scale in cartographic terms. The base map and layer swapper feature allows the user to toggle different layer displays on the map. Only one base map may be displayed at any point, while multiple overlays may be included or removed from the map at any time. The overlays are separated into two sections, cumulative years and individual years. Cumulative years display the number of layers they represent beginning at 1, which represents 2001, and ending at 14, which represents 2014. For example, 7 represents 2007. It displays data for 7 years beginning in 2001 and ending in 2007. Individual years show data only for the year they are named for. For example, 2007 represents data for the year 2007 and nothing more. The time slider feature allows the user to explore cumulative tree loss with 14 ticks, each of which represents the following year, which also includes all previous years. The layers displayed here are taken from the cumulative years layers in the layer selector. The bar chart feature displays all of the data separated into years. Each pixel on the map contributes as 1 on the x-axis under its corresponding year on the y-axis. To see the exact number of pixels for a given year, the user may mouse over any of the bars to have the number displayed. The legend is a toggleable feature which reveals the pixel color associated with each year. The color scheme is sequential to allow the user to more easily differentiate tree loss that occurred longer ago or recently. We use neon colors to highlight the contrast between the black no data pixels and tree loss pixels. The Minimap feature allows the user to reference the area they are exploring on a smaller map scale. It can be downsized at any time if it proves distracting to the user. The information feature is a simple introduction included to briefly familiarize the user with the features of the application as well as its purpose. The info, legend, and chart togglers allow the user to toggle the display of the associated features. This allows the user to remove any potential distractions from the map or include them at any time. Now, we will demonstrate how this application could be used to discover relationships between tree loss and various other aspects by a user. First, let's zoom to Puerto Morona, a mining hotspot which has recently been the site of conflict between locals and miners. The user would likely wish to see the amount of tree loss that has occurred there, so let's up the transparency slider for all data. Maybe the user would like a more realistic view of tree loss, or to see how accurately the data encompasses tree loss. Let's change the base map layer to imagery and streets, which displays reliable satellite imagery of the area with political boundaries and names still applied. Notice how the data overlay clusters to brown areas on the base maps. Recall that our data ends in 2014. Some of the loss in the satellite imagery is likely from 2015 or this year. Now, the user would likely want to delve a bit deeper into the data. Let's take a look at the bar chart. Notice 2012 and 2013 have much more tree loss than other years. Interesting. Let's include an overlay of 2012's data alone to see if Puerto Morona has more tree loss in that year than others. Now, let's compare it to all of our data. Compared to all years, 2012 seems to have a fairly average amount of tree loss for this area. Now, let's turn on the layer for 2013. It's very clear that this year held much more tree loss when compared to all data. Notice the lines that appear in the data. It is possible that these represent roads, which represent infrastructure and development. The loss in this specific area may be due in part to legislation passed in 2013, which made Ecuador much more lucrative for foreign mining investors. To get a better understanding of the recent history of Puerto Morona, the user may wish to use the time slider feature. Let's do that now. Using this feature reinforces the idea that mining was heavily influenced in 2013. Now, the user could use similar methods to inspect other mine sites, or they could use Zoom Home to explore different base maps to compare tree loss to national reserve boundaries or other aspects. This concludes the introduction to the Mapazon application. Friends of the Amazon is comprised of members Jacob Marquardt, Charles Kruger, and Skylar Roth. We would like to thank Dr. Alan McEachran and Morteza Karimzadeh for their guidance and for providing us with the opportunity to develop this application. Thank you for watching.